Hi, it's Gadget UK here again, this time looking at a ZX Spectrum. So this was given to me by a good friend of mine, Dr. Andrew, actually. It was, I think it belonged to one of his daughters when they were younger, and it was going to get skipped, and he rang me up and said, Chris, I got all this stuff, it's going to go in the skip, do you want it? So I said, yes, absolutely, please do not throw away any vintage retro computers like this. So anyway, we did the stuff that I'll show you in the live stream in a minute, and then some stuff at the end, cleaning it up, and I sold it. Didn't get very much because I wasn't aiming for I didn't want lots of profit off this. I was just trying to restore it and pass it on. Anyway, it sold on eBay, and I got a feedback. Everything was great. He was happy with it. And then about a month later, so I think 2 months in total perhaps, it's failed. And the guy contacted me on eBay and said, look, this is what's happening. I'm getting blocks all over the screen. It's not working. Is there any chance you would know what's wrong with it? Is it the RAM? Can you fix it? So I said, yeah, look, no worries. Send it back to me. It's the least I can do. You've not had it very long. It does sound like maybe the RAM has failed. Now, I did test this thoroughly before it went out, and it was 100%. But it's just one of the consequences, and this is one reason why I tend not to want to sell things on. A lot of things I keep in my collection, excess things, you know, obviously I have to sell on. But yeah, anyway, this is a good example of how some of this old stuff, even though you can test it and test it and test it, you know, 2 months later something fails on it, and this was recapped, as you'll see in a minute. Best to start with this way. Yeah, so let's do that one first. Again, try and support it as you try and pull straight up. I'm sure these are going to break before we're done. Oh, God, I'm stiff. I think someone said put IPA on those, and that's a good idea actually. If you want to assist getting them out, just put a little bit of IPA there. Let's try and do one over here now. It's bent over, that one. That's what I don't like about that one. You've got to, that's it, bend it a little bit to try and get it off. Anyway, that's that done. Now, handily, I printed off a piece of paper here with the IC position numbers. So IC23 is an OR gate. And I had a quick look at the schematics. I was going to show you, but the print is really small. The issue 2 schematics are awful, the ones that I've found. But basically, in order to add this RAM to the system, there's 2 things you need. You need the RAS and CAS stuff, you know, for the RAM refresh. But then also, I think there's 2 multiplexes, isn't there? Yeah, the HC157s. We've got 2 of those. Because I think, are they 4-bit each? It's like 2 inputs, 1 output, but I think it's like 4 channels there. So you need 2 of them to get 8 bits. I think that's why we've got 2 of those. I think from what I've read online, they're saying you can either use the HC chips or LS chips. So where's IC32? Yeah, 23, 24, 25, 26. Yeah, so 23. Let's get that one in. It's nice at having these sockets on. I'm not sure they all shipped that way. I don't think. You know, the OR we've just fitted there, that's an OR gate. So you've got, you know, 2 inputs and you know, 1 output. It's one or the other, you know. And then same with the AND. You've got 2 inputs and 1 output, and it's an AND gate. This one wants to go in IC24. The clue is it's a small socket. I'm not sure why I'm looking at those 2, because this can only go in here. And I'm guessing pin 1 is the right way up there. Yeah, I think so. So that's those 2 done. These 157s came from Allison stuff again. It was when I got to one of the drawers of the components that came from Allison, I realised that she just happened to have 2 LS157Ns. Yeah, the legs on this one are totally gull winged, so I'm just going to put it on the mat and squash it down a little bit. There we go, that's better. To straighten them out. Get that in there. So the only other thing we need there now is the RAM. Mitsubishi 5K4164. Might just have enough of those. I know I've got a Kyocera one there. Might have to mix and match them a little bit, I think. So let's try and take those out. 1, 2, 3, 4. Got to be careful because I've got some Toshiba larger ones there. 5, 6, 7. I think the 8th one's there. Yeah, 8. That should be enough, I think. So let's get rid of that. Just check which way pin 1 is. Yeah, you can just about see on the silk screen here the notches at the top. We'll try and get these in. Right, so we've got all the chips in there. We need to get the keyboard back on now. That's it, that one's in. I think this one's the one. Hang on, no, that's the one. Yeah, this one just you do it that way from the back. It's easier, and this one it's easier to do from the front, just because of the very bent over. So move that back a little bit. You can perhaps just about see what I'm doing. It's a bit dark. Hopefully, we won't need to go back in there again. Oh, I know what the issue is. I'm being a complete muppet. That's what the issue is. Let me take this back over there. We need a jumper. Yeah, the reason it's missing a link, if you remember in the previous video, one of the things I was talking about is you sometimes on the revisions you've got some jumpers up here that specify the types of chips you've got on there and whether it's the lower half of the chip that you're using or the upper half. And the reason being is that Sinclair bought the 4164 chips that were faulty in one half. They got them cheap, you know, so like when the manufacturers these were testing, if they found a problem, typically you just get they might find a problem in somewhere in the chip there. If it was just one location, it happened to be the lower half, they would stamp it and mark it so that Sinclair could use it as the upper half of that chip, the 32K in it instead of the 64. So you need to change that jumper. Mind you, thinking about that, I don't know whether that's going to cause the issue because I know it will. It'll be floating. So it's like 1 minute it could write to the upper of a chip, and the next minute it's right to the lower of a chip. If that's going to be floating, I think. Yeah, it could. If the upper address bit's floating, that would cause all sorts of weird and wonderful things. You got a pad there, a pad in the middle, a pad there. It could be those. Could be those 3. Yeah. So that side's ground. Yeah. So you've got 5 volts on one side of this jumper here, ground on the other side. There we go. That's one side. Get the solder off the iron and just hold it down a little bit as we flow that. Yeah, that's it. So we've got a little itty bitty wire there. That's hopefully now enough to get it to work. I don't really like sticking it on there. Let me think. Let me just get the meter. Let me see if there's a cap on that same 5 volt line there. Because when you try and clip those little croc clips there onto a chip leg, it's easier to bridge the rail to something next to it. You know what I mean? It can, if you were to stick it on, I don't know, there for example, it could rotate, it could slide round and short the pin next to it. So let's just measure from one of these here. Yeah, that one is. I'm surprised how long it took me to find a cap there on the 5 volt rail. So we'll connect that there, connect that to the heat sink. I think that should do. Power it back up. Make sure I'm getting video. Yeah, you can't see that, but I'm getting video, so it's on. Let's have a look at. I think this one was the ore, wasn't it? So we've got pulsing. Pulsing is an input. Pulsing. So we should see some pulsing. Yeah, we do. I think he goes input, output. We'll soon find out. Hang on. Pulsing. High. Tell you what, that's getting incredibly hot. ULAs do though. So pulsing and high. Yeah, because it's an ore, it's just going to stay high, isn't it? Because one of those inputs is high. And that's the ground. Let's have a look around the other side. Again, I'm not sure if that's an output. That's red hot, that heatsink. Pulsing. 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 I think that one's alright. I think this one's an and, isn't it? So it's like high. High should give us a, hang on, a low. Or is it a NAND? 0, 0. Let me just check that. It could be a NAND. Yeah, so that's correct then, isn't it? It's a NAND. The output is inverted. So if we check that again, we've got a high and a high. So you'd expect on a normal and that would give us a high. Because it inverts it, it should give us a low when it's doing. That one's pulsing and a high. I'm trying to think what you get on an output now for this. Is it going to be pulsing? Yeah, it's going to be pulsing. Ground. Pulsing high. Pulsing low. Yeah, I think that's right actually. I'm not sure which is the output there. Is it the pulsing low or is it the pulsing high? I don't think it matters actually, thinking about it. So we've got a low and a high. Yeah, sorry, a high and a high is giving us a low, and that one's pulsing and a pulsing low, yeah, and pulsing. It's giving us, yeah, it's giving us pulsing. I don't think that's the issue either. Without the pin out for that, yeah, that one's floating. That one's floating. Let's just compare to this one here. Ow, that heatsink's red hot. Yeah, I'm starting to question that chip there actually. It's got a floating pin. Another one floating. Let's switch it off. What I might do is just go and quickly shoot into the other room, into my component trays, and see if we can swap out that 157 there, because that might be the issue. Yeah, I found a 157 here. It's a different manufacturer. I'll show you. It's I don't know what that is. Is it RS? Looks like it's got the RS symbol. It says Portugal. So let's just put that down there. Get the wrist strap on and stick that in. I mean, it could be some corrosion in there. I don't remember why that pin's gone weird. I might have to just put a new socket on it. Let's just move that out of the way. Power it back up. Oh, I've wrapped that under there now, look. Let's just probe that pin again. Hey, look, we've got signals now, look. You see that? Hopefully that's visible. You saw that was floating before. One or two of these here were floating. I think that's the issue. Just my luck to find a faulty 157. Blame Alison. That was one of Alison's chips. It's a good job she had 3. The funny thing is, I had that chip already lined up to test to start with, and I swapped it for this one. The reason being, you can see that one's a Texas Instrument. Can you see the little, yeah, it might not focus very well, the little Texas Instrument icon, the symbol there. So I put 2 Texas Instruments ones on there, and put that one back in the tray there. It's only as a consequence of everything we've been doing here that we've obviously worked out, I think, that that's the fault, hopefully. So let's disconnect that. Yeah, having worked out that chip's not right, if I switch it off and on, just watch. You see how short that black screen was? It's still not right. I've got the one that's a different make there. I could try taking that Kyocera out and swap, and that one, we've got 2 Kyoceras there. So I could remove those in a minute if that doesn't work. We'll try that. Let's see what happens now. Watch how long the black screen stays black. That's like twice as long, isn't it? Yeah, there's definitely a change there. Anyway, so we've covered all the recap stuff there. You've seen all the other stuff on the live stream there. So this is me re-receiving it back today. I got a letter here. You can see, hi Chris, thank you again for taking time to look at the issue with the ZX Spectrum. So yeah, it belongs to Adam, this. So anyway, let's go. In fact, before we go and plug it in, I'm going to unscrew the screws here. We'll just make sure that there's nothing loose, because there are some socketed chips. You never know, maybe one of those chips came out a little bit in transit or something like that. So it's looking fine on the inside, actually. We can try and just press these chips down, but yeah, I don't think that's the issue, to be honest. So the question is it going to be the lower RAM or the upper RAM? Well, I think the upper RAM is kind of, on a 48K, is video and upper RAM. So the fact it's not booting at all would perhaps point to lower RAM. But I mean, we could have a ULA fault. I hope the ULA hasn't died on this. Well, as you can see, that's actually powering up. I did have an issue a minute ago. Yeah, it's going straight on black. Look, it goes black then straight on. So the upper RAM. Well, we've got another issue there, look. I don't know what's going on with that. I think it's the upper. Yeah, because it's only passing a... Yeah, you can see what's happening there. The screen goes black, literally for a very split second. That is not what you would see if this was working in 48K mode, and obviously weird things are happening. So actually, it looks like it's the upper RAM. So it might be a bit easier because it's socketed. The other thing is there's kind of like a yellow tint to the display there, and that's going to be one of these variable adjustments. You know, there's a couple of variable caps on there, and a couple of variable resistors. Look at that. Just touching that seems to have solved it a little bit. So yeah, we need to adjust that. Maybe even get some deoxit onto those pots and just tweak it a little bit. Weird coloured blocks and things. That is not normal, so I think it's the lower RAM actually. What I'm going to try and do, I think, is the piggyback approach. I'll find, in fact I'm not so sure, because you've got multiple voltages on these, it's very important that you don't lose a voltage. So piggybacking on chip switch has got a 5-volt connection and ground. It's fairly safe, but on these, if you miss a voltage you can damage the chip. I'm pretty sure though it's going to be a RAM issue. Yeah, so it's that one there needs a little bit of contact cleaner in there, just a little bit, and a slight adjustment. But the RAM issue, it must be one of these. It must be one of these. So one of the first tests you should do on one of these is to measure the voltages. If we measure from ground, the modulator cam there is ground. You can see we've got, that's 12, and actually it's a bit low. It's 11. And then we should have +5, we should have -5, and we're missing a -5, I think. So switch it off. It would appear that we are missing the -5 and the +12 is a little bit low. So looking at the schematics here, the area that generates the voltages is here. I can sort of show you that to zoom a little bit. It might move around a bit. This, can you see -5? So the -5 comes from over here. So we've got like a Zener 5V1 diode, resistors, another diode or two. But ultimately, sorry, I knew that would happen. This is what I said about might jump around a bit. But ultimately, it could be TR4 here, because remember the +12 is a little bit low. The +12 comes out here on the side over there where the collector is. So yeah, I'm kind of thinking TR4. It's a ZTX 650. These fail quite a bit. So I'll get the board out, we'll have a measure around there just to see what's what. Yeah, I think we'll take off the ZTX 650. That's here, the TR4. Because everything around here looks okay. The diodes and things are okay, resistors are okay. I think it's going to be that. It might not be, but yeah, they do fail a fair bit. And in fact, I've got some replacements that came from Ian Scott Johnston on one of those live streams that I did. So thank you very much for that, Ian. Hopefully that might just get this board out of a pickle. And if that's the case, it's not going to cost this guy anything, because I won't be charging for this. I kind of seen it as a warranty issue myself, if I'm honest. Even though he's left me a feedback and it's a few months later, well over a month later, not far off 2 months later, I feel it's kind of it's only fair really, because I know I'd be a bit annoyed if I'd bought something and 2 months down the line it had failed. So we'll just add a little bit of solder to the 3 points there and just make it a bit easier to remove, because it's got some flux in there as well. And we'll just use the engineer solder sucker here from Andrew Littleboy. give that first one another go. And then the way I remove these is just heat and just wobble the thing from the other side. You can see the middle pins moving, look. That pin there's still stuck, so we'll just wobble it a bit. And if you continue to wobble it, there you go, it remains detached. Let's just do that top one again. That's the only one holding it now. There we go, it's out. Don't wrench it off, obviously, because you'll damage the pads. Anyway, let's get the component tester. This component tester came from Alison Shallis, actually. So it's a bit like a community repair, this, isn't it? It's like, okay, you got me doing the desoldering and stuff, but this meter came from Alison, the engineer pump came from Andrew Little Boy, and the soldering iron came from Dermot Sweeney. Yeah, this channel is sponsored by the community. Here we go, switch it on. Short circuit on green and blue. And yeah, I'm pretty sure they're not shorting. Try it again. Short circuit on green and blue. There we go. That's why it's not working. So the ZTX 650 can be replaced with ZTX 651. You can see these came from the Retro Computer Shack. And obviously, and ultimately these were the ones that were provided by Ian Scott Johnston. So it is a community repair, this. I shouldn't be handling it like that with my hands. Anyway, let's just retest on here. I'll just show you. The pins are not shorting. You can see here, let's just get you a look at that. They're not shorting. The clips are isolating the edges, but it is saying short circuit on blue and green. So anyway, let's just remove that. We'll connect up the 651. Just pull the legs apart a little bit just to aid with this. That's the red. Doesn't matter the order you get these, it's quite intelligent. Like a lot of these component testers, these are the best ones though, the Atlas ones. They'll cost you more money, but that's what you want to get if you can afford it. There you go, NPN silicon transistor. So we've proved without a doubt there, it's definitely that transistor. What we've got to hope is that the RAM has not died as a result of lacking the -5 there. To be fair, I'm amazed it was working at all without that -5. The -5 may be something to do with the refresh. We might be lucky. It might have died, or more likely have died, if the 12 was missing. Whether this is lowering the 12 volts remains to be seen, but I think so, because the 12 comes from that area of the circuit as well. So the silhouette of the silk screen here, kind of this like angled bits on the left hand side of it, and if you look at the front of that, you can see on the edges of the front, it's kind of beveled on the edge, so it goes this way with the writing to the left hand side. So let's just get that on. And of course there could be a reason why this has failed. Something else in the on the board there could be the issue. Let's just try and push that into position. There we go. I'm going to leave it fairly long just to allow it to stand off the board a little bit, really, to get a bit of space. Now I think the nice thing is with the 651, it's it might be a slightly higher spec transistor. I might just compare that in a minute, do a bit of checking of the data sheet for it, which means it might be a bit more resistant to failure. So let's just snip the legs off. Now I am of course assuming that the orientation is the same here. Yeah, we'll clean the flux off there in a minute. Let's just get that out of the way. So the next thing I want to do is just get the heatsink back onto this and go and give it a test and just see if we've got the right voltages there. And if I measure the voltages here, now we've got -5, you can see, 479. It's a little bit low, but that's correct. That's what you expect to see on these. +12 has gone back to +12. It was a bit low before. And the +5, which was okay, is still okay, 4.89. So let's give that a try on the TV. And if we just power that on, you'll see we're not getting the weird stuff we were before with the green blocks and things. The Sinclair research thing bobs up and down a little bit as it's my TV's syncing, but I've seen that before with certain composite signals, so I don't think there's anything wrong with that now. So the next thing to do is reintroduce the upper RAM. I'll just get the ESD wrist strap on, because we're obviously handling chips here and I'm on carpet. Not ideal, but it'll be okay provided I am wearing the wrist strap. Now let's just move these in. So I've got a 157 wants to go up here. We'll get the logic in first, I think. This one wants to go in here. And as you saw in the live stream parts of this earlier on, the way I implemented this, we're using 4164 chips here, which are twice the size that are needed for this machine. And the little wire link you do underneath determines whether you're using upper 32K bits or the lower. Is it 32? I think it is. So if there was ever an issue in one half of one of these chips, you could just change that jumper over and it would be operational again. So anyway, here we go. That's the last one. So let's give it a try. So connect the power. Yeah, that's right. The length of time it shows the black screen there is easily twice as long as it was before we fed that RAM. So I'll just test this now. I'll run some RAM test software on it, test some games and stuff, give it a really good burn-in test, and we'll get it sent back to the chap. Also interesting that we fixed that yellow tint issue as well. I haven't had to do anything with the variable resistor like I thought I would, because I did do that earlier on actually before I sold it. I dialed it in perfectly so that the colours and the contrast, everything just looked perfect. Anyway, let's play some games. So it's passed the school days test there. I always generally use this game to test, amongst other games as well, as you'll see. But what I like about this game is it was such a complex game. It used pretty much all the RAM, I'm sure. And you would notice very quickly if there was some issue there. I mean, you can see the colours rotating a bit. That's the composite thing. I'm not even sure if that's coming out very well on the capture. You know, little rolling bars there from the chroma signal. But it's fine. It's fine. You know, if you had a RAM issue, this game, you know, running in demo mode, would not run very long. I am sure of it. So we'll just clean up the points there where I soldered that new transistor on. While I'm here, it's worth pointing out it's very important you don't use a power supply that outputs more than about 9 volts. You can get, you know, some people will tell you, I'll just use a Mega Drive power supply. Don't do that, because those output like 14 volts. And the heatsink here will get super hot as the 7805 burns off that additional voltage. So try and get a 9 volt power supply, and if you get a really cheap one, measure it before you try it. Make sure it is pretty close to 9 and it's not like 12. You just want like 9 volt 1 amp and just check the polarity is correct. Something else I think I'll do while I'm here, and this is something you could say has been overlooked, but it's not really a problem at this stage, is just to reflow the power jack there. Can you see the solder points? They're not that great actually. We might have the start of a bad solder point there. That's something I overlooked. So yeah, it's not going to do any harm just to add a little bit of fresh solder here. Wow, that is not melting. There we go. I literally did just switch the iron on, so it was bound to take a few seconds to get up to temperature there. That one's okay. Let's redo these. You can see I've still got the Futurist 8-bit cart plugged in there. I've been using that for testing. It's a great cart. I'll do a review of that soon. The interesting thing is that cooled down there, it went a weird shape. I don't know if you saw that. Let's just remove that old solder actually. Because A, we've got too much, and B, I don't like the shape it went. So the board is all screwed back in, it's all cleaned up, and we're ready to go. I'm going to connect the keyboard back up and then just test it loosely without putting the 4 or 5 screws on the underside, just to make sure that everything looks okay and everything works and that we don't need to take the board back out again. This transistor here, I bent it away from this heatsink because, as I say, this heatsink gets incredibly hot, and if it's straight up it's fairly close to this, so the area around here does get super hot. So the further away, if I suspend it a bit further, the further away from that heatsink, the better, really. That's probably not why it's died. It is quite common for those transistors to fail, and I think maybe the 651 is a better substitute to replace the 650 with. So I got the colours dialed in a bit better there. It might look a bit washed out just because of the angle the camera's at. But yeah, it's looking much better. You know, the colours are much more stable. Yeah, I think that's about as good as it's going to get visually. And Operation Wolf is looking pretty good there as well, actually. I can never remember what the fire is on this. Is it space or is it something else? The fire button is the space, which is ridiculous, absolutely. Might be better on other spectrums, but on this one, oh yeah, it's a pain having to hold space down. But it looks really good. Yeah, there's some dot crawl there, but yeah, that looks really good. I'm pleased with that. So I only charged him for the postage. I didn't charge him for any parts or any of my time or anything like that. And it got back to him okay. And lo and behold, a week later, I got another message to say that it wasn't loading games. So I was like, oh no, these blasted spectrums, you know, they just have fault after fault after fault. So anyway, I spoke to him a little bit more and said, can you do a video of what's actually happening so I can actually see and hear the tape loading. And he uploaded a couple of clips and I could hear the sounded a bit wobbly. So what I mean is instead of a constant sort of regular velocity to the tape playing, you know, where the frequencies sound a regular pitch and tone and stuff, that wasn't happening. It was kind of variable. So straight away I was like, hang on a minute, that sounds like the tape deck. So I said to him, are you sure it's not the tape deck? Oh no, it's not the tape deck. I'm sure it's not. I'm sure the tape deck's fine. I said, I am sure it's the tape deck. I tell you what, send it back to me and I'll check out if the ULA needs replacing, because that can be a problem sometimes where they stop loading. And he hummed and hawed about it for a little bit and then said, hang on a minute, I'll get back to you. I've ordered a new tape deck, let me try that. A week went by, he got a new tape deck, and lo and behold, it solved his problems. So I am super appreciative that he did follow my advice there and replace the tape deck, because that's what the problem was. Anyway, I do hope you found the video interesting. A special thanks not only to my patrons, but all of the people that have been mentioned in this video. You know, we used parts and this and tools and things from various people here. Alison, Dermot Sweeney, Ian Scott Johnston, Andrew Littleboy, and of course my friend Andrew, who originally provided the Spectrum. If you'd like to support the channel, please see the Patreon and Coffee links down below. Thank you to everyone that comments and subscribes and supports me. I'll catch you in the next video.